implementation plan for my text-based game in Erlang. So yeah, this sprint I decided to just do a lot of designing because in the past my approach has usually been to jump in head or feet first and just kind of hack something together. So I thought it'd be nice to plan something before getting into it. So unfortunately, that did mean that I didn't actually get around to implementing, but I have a really well thought out system. So uh, this is just my design document. This is what I worked on. So here I talk about the ECS entity component system paradigm used in a lot of Rust libraries such as Bevy, but since this is not Rust, I was not sure how to approach that. So let's see, we have the implementation plan, front end, user interface. Yeah, nice table of contents right there. So front end, user interface. Because this is an Erlang, my idea was to do things with processes, obviously, but I thought that with Erlang, there has to be some way to easily do a multiplayer text-based game because you could have a window that displays text to the user asynchronously from user input. So user input, you type in a message, it shoots it off to the server processes it, sends an output message to your terminal, which then prints it off. But note that the command being parsed, it just gets sent to the server. It doesn't actually return this string to display what happened, if that makes any sense. It's like a call and response type thing, meaning that if you don't type anything but another player enters the room that you're in, then it would say like, oh, a knight walks into the room. Then you would know like, oh, cool. Some interesting stuff. Yeah. Then on the back end, you have a syntax parser. So direct object comes after the verb. Instrumental object is usually preceded by with or using. So complete commands have a verb, direct object, and an instrumental object. I should note as well, I've realized a command can also just be a standalone verb, such as look or inventory. So the 4 steps I came up with to parse a command sentence: strip all the articles, identify the verb, which should be the first word, identify the direct object, is the noun that the verb comes right before, then identify the instrumental object as the noun that comes right after with or using. The reason that I do this rather than just splitting it into different words is because what if you have a object whose name has spaces like a smelly troll or a rusty sword? In that case, this still allows you to do things like that. Let's see. Oh, and also it has an action thesaurus, which takes other verbs like go and move and identifies that they're actually the same as just move. So text response generator. A lot of this is kind of hazy. I didn't get super far in the implementation, but the idea is that I write all these different components as generic servers. So the text response generator will generate a description of the current zone, including like the room description, all the items that are currently in it, whatever entities might be in there. Gives success and failure messages back, depending on whether it actually works. For instance, if you try to move north and you can't move north, it doesn't work. Failure messages such as when you try to execute a verb that doesn't exist, that's not valid. So then we have, I called it the WEM, partially because I thought it was fancy, but really it's just a virtual dungeon master. My idea with this is that the DM can handle asynchronous, well, maybe not asynchronous, but like just events. So everything exists as a state machine. So the dungeon master can coordinate actions between different state machines. So like pull a lever in one room, bam, hear rumbling from banquet hall, a secret door has opened. So then player registry. This This is kind of a custom registry thing, because Erlang you can already register processes under names, but I thought it'd be good to have a custom player registry that let you actually assign players to player IDs or usernames. So then you have the door registry, which just tracks doors. They can be thought of as the edges in a graph of zones. And by the way, zones are just what I'm calling the rooms. So a zone can be like a cave or a room in a tavern or something. I don't know. And then object registry does same thing just for objects. So action requests, pretty standard. This is just kind of describing the client-server relationship. I'm calling them things, which can be objects, entities, or zones. You could also call this like props, actors, and rooms if you wanted to. But yeah, objects, well, they're all state machines and they have state, right? So the game spatially is organized kind of like file directories. So it can be, I don't know, if you wanted to, you could have a room that goes north into itself. There's no escape. That'd be kind of funny. Then this is kind of taking a page from the classic Zork. I use flags such as attackable, alive, edible, has HP to determine what's actually a valid action to take with an object. For instance, if something isn't a container, you shouldn't be able to put things into it. Or if something isn't alive, then it can't be killed. If something isn't attackable, it can't be hit or swung at. If something's not edible, you shouldn't eat it. So then I was just going to represent everything with JSON. Then the state machines, I was thinking they each have a type so that you don't get confused. As I mentioned up there, zone entity or player entity. I should add thing to this, or object. Yeah, object or prop. But I do make a distinction between entity and player entity. And then each state machine also knows about its parent so that things that affect everything in a room can affect things in containers, maybe? I don't know. And then the map loader, I was just kind of spitballing here, but map loader would just be something that runs on startup that reads through the whole directory of JSON files that represent the game world, which then, I don't know, makes state machines, initializes everything, puts it all together. So yeah, that's my whole design.